Hello to you all. Welcome to another session here with us at Mathematics Resource Center. And today we will be doing the solution to some CSEC past paper questions. And this is just a little quiz that my students did, and we're doing the solutions live. Okay, so if you haven't done so as yet and you're joining us for the first time, go ahead and subscribe, right? And after subscribing, please click that bell so that you can get notification every time we go live and every time we have a new video uploaded. All right. And also go ahead and share. Copy the link and share so that other persons can benefit from this session. All right. So just a minute and we will get started. Once again, thank you for joining us. And I trust that this lesson or this session will be a good one for you. And remember to leave comments to let us know how we did, and so we can always improve to make it better for you, our viewers. All right, thank you all. All right, so we're going to go ahead and we're going to get started. All right, so here goes our quiz. And here. All right, so here we are. We get started. All right, so this question, right, and as said before, these are all CSEC past paper questions, right? So this question says, using a calculator or otherwise calculate the exact value of the following. And the question is 4 1/5 times 1/3 minus 1 1/4. So when we're doing a question like this, the first thing that I want you to do is to always change your mixed numbers, right? So your mixed numbers into an improper fraction. So you're going to change out all your mixed numbers into an improper fraction. Let's see if we can zoom in a bit, right? So that it would be clearer for you all. Okay, so we go ahead and we are going to change 4 1/5 to an improper fraction. And when we're doing that, we're going to multiply the 5 times the 4, which gives us 20, plus the 1 here, which gives us 21. All right, so it's 5 times 4, 20, plus 1, which gives us 21. So we've done that part. And the next part is 21 over the denominator that was there, which is 5, times, and we have 1/3. It's already, it's not a mixed number, so we just write it as it is, so 1/3, and then minus, we have 1 1/4. So we're going to change that into an improper fraction. So we're going to take our denominator, which is our 4, multiply that 1, it says 4 times 1, which gives us 4, and then we add that numerator. All right, so 4 times 1, 4, plus 1, which gives us 5. So it's 5 over 4. Okay, so now that we have changed all our mixed numbers into improper fraction, we can go ahead and do our calculation. And when we look at it, we see where we're doing a bit of multiplication and we have some subtraction happening. So thinking about it now, the first thing that should come to your mind is BODMAS. All right, so the very first thing that should come to your mind is BODMAS, knowing that we are going to do our bracket, right? And then we're going to do multiplication or division, whichever one comes first, and then subtraction or multiplication, whichever one comes first. So you can say BOOMDAS, or you could say BODMAS, or you could say PEMDAS. It doesn't matter which of these you're familiar with. It's the same procedure. All right. So we're going to do our multiplication part first. And when we look at 21 and 3, we realize that we can simplify that part. So we can simplify the 21 and the 3. So 3 into 3, 1, 3 into 21 goes 7 times. So I'm going to go ahead and I'm going to do the multiplication. So I'm doing this part. All right, so we're doing this part first, since that is the multiplication. So we'll go ahead and we multiply, and we say 7 times 1, and that is 7. And we say 5 times 1, and that is 5. So we now have 7 over 5 minus 5 over 4. And now we look at the the operation between the two fractions, and that is subtraction. And when we look at the denominator, we realize that the denominators are different. So when you're adding or subtracting two fractions and the denominators are different, then you need to find your LCM. Or you can find, make them, the denominators have the same, make the denominators the same, right? Or you could put it as equivalent fractions, right? So whichever way you want to phrase it, it's basically the same procedure. All right, so what we're going to do now is, looking at the denominator here, we have a 5, and here we have a 4. So 5 and 4, what's the LCM of 5 and 4? The LCM of 5 and 4 would be 20. So now our fractions are going to have new LCM and that new denominators, and that denominator is going to be 20 for both of them. So changing out the denominators, the denominator is going to be 20. So now I'm going to say, what did I multiply 5 by to get to 20? So since I've changed out these denominators, the new denominator is 20. How did I get from 5 to 20? Oh, I multiply by 4. Good. So if I multiply by 4 to get the new denominator, I'm going to multiply my numerator by 4 as well. And 4 times 7 is going to give me 28. Good. And then now for the next part is the 4 and the 20. So my original denominator was 4, and now my new denominator is 20. So I'm going to say, what did I do to 4 to get to 20? I multiply by 5. So since I multiply 4 by 5 to get to 20, I'm going to go and do the same thing to the numerator, which is to multiply it by 5. And 5 times 5 gives me 25. Good. So now that my denominators are the same, I can easily well go ahead and subtract or add. So anytime you're doing fractions, you're adding or subtracting fractions, you always need to make sure that the denominators are the same. All right, so we can go ahead and say 28 minus 25, and that gives me 3 all over 20. All right, and for that, it is 2 marks. So for that, it would be 2 marks. So I give you, say, a minute or a minute and a half to copy, right? And then if you have any question, I will be taking that question at this point. So if you're joining us from YouTube, welcome, happy to have you joining us. And if you have any question, I'll go ahead and take that question at this point. So you can go ahead and comment in the chat if you have any question. There's anything that you weren't so sure about, and we can just clarify for you. Right. So I take it that we can move on now to the next question. All right, so we're going to move on to the next question. And coming down to the next question here, it is 4.1 minus 1.25 squared divided by 0.05. All right, and what we're going to do is we're going to do the numerator first, and then we're going to divide that result by the denominator. But before we do that, let me just ask, we have 1.25 square, what does that mean? Or if it's the case where you have 3 square, what does that mean? Or 5 square, what does that mean? X square, what does that mean? So 2 square means 2 times 2. 3 square means 3 times 3. 5 square means 5 times 5. 6 square means 6 times 6. X square means x times x. So here we have 1.25 square. So we know we'll be multiplying that 1.25 times 1.25. So let's just write it out a bit. So we have 4.1 times 4.1 minus 1.25 times 1.25. All right, divide by 0.005. And you can go to the calculator and you can put the numerator, go ahead, put the entire numerator in your calculator. So you can press 4.1 minus 1.25 times 1.25. And your calculator is programmed to operate in the BODMAS procedure. So it would actually do the multiplication before the subtraction. So you don't need to worry about that aspect, right? So you can put all of that in the calculator. And you could also have put the numerator originally in the calculator without rewriting 1.25 square as 1.25 times 1.25. So what you could have done is on your calculator, you would press 4.1 minus 1.25, and I know you might not be able to see, oh, yeah, you can see. All right, so if you're able to see, maybe not, but there's a little arrow on your calculators for some persons like that, right? Or for other person, you might see an x square, or you might see both on your calculator. Either one, you can press the x square, and that will bring up the square, or you can press this one here, and that will, when you press that one, you'd press 2, and that would square it for you. All right, so either one. So we'll go ahead and we'll put that into our calculator, and we get the same answer, which is 2.5375. All right, and divided by 0.005. Okay, so it's 2 marks. So I expect you to put this step in and then put your final solution. Yes, you could have placed all of this into the calculator at once, and all you would have gotten from that is your final answer, and that is just 1 mark. All right, so this step is important. All right, so we go ahead now and we divide. So you can just press divide on your calculator, given that you haven't erased the 2.5375. So you press divide by 0.005 and equal. And you write down your answer, which is 507.5. All right, so there we go for the second question. I give you a minute to copy, and then we move on to the next question. All right, and if you have any question concerning this one, you can go ahead and message that, send it in the chat, and I will just respond to you immediately, okay? Okay, so we're going to go ahead and we're going to move on to the next question. All right, so we're going down to the next question now. All right, so this question says, factorize the following expressions completely. And we have 5h squared minus 12h g. All right, so in factorizing this, we're looking at both terms and we're looking to see what it is that we can divide into 5h squared and also divide into 12h g without leaving a remainder. And another way that we can put it is to say that we are looking for the HCF, all right, of 5h squared and 12hg. All right, so when I look at 5 and 12, the highest number that I can divide into 5 and 12 is just 1. All right, so I could put 1 as a part of my HCF, or I don't necessarily need to put that one because it won't make a big difference, right? And then for my variables, I have h squared and h. So I realize that my h are common. So it's a part of my HCF. And I look at the g is not common, so it's not a part of my HCF. All right, so now I go ahead and I open my bracket. And for the variable, you always make sure that you write down the lowest power of the variable that is there. So let me just rewrite this over here. So I have 5h squared minus 12hg. And the power of the h here, the second h is 1, and the power of the g there is 1. So in writing down my HCF, it's the variable that is common and the lowest power of that variable. All right, so if it was a case where we had 4, then I know that 2 would have been there because the lowest power of the h would have been 2. All right. Okay. So that's it. So now we're going to go ahead and take our 1h, not square, 1h, good, and divide into our 5h squared. So we have 5h squared divided by 1h, or we could just say h, right? And that is h into h1, h into h squared, h. So 5 times h just give us 5h. So here we say we have 5h. You don't need to show this step over here. You don't need to show that any at all. All right, but that's just support for your support in the event that you're not so sure what is happening. Good. So we continue. So we're done with the first term and we move to the second term. And we're taking the same HCF and we're dividing it into the second term. So it is 12hg divided by 1h. So we say h, cancel h, and we're just left with 12g. All right, so we have our sign minus 12g. Those brackets. And there goes our answer. All right, so remember this bit to the side is not important, right? For you to write down. You can do this, all of this mentally and just write in your answers, all right? And that's the expectation for the exam. You got to practice how to do these questions mentally so that you have the best use of your time in the exam. All right, so I'm just gonna go down to the next question now. And this one is quadratic. So it is, rewriting it, so it is 2x squared minus x minus 6. Just rewrite it just in case it's a bit small. So we're asked to factorize completely. And looking at this quadratic, the first thing that comes to my mind and always come to my mind when I'm factorizing a quadratic is the ACB method. So ACB method is one where we label our numbers. So the coefficient of x squared would be a. The coefficient of x, we're not seeing a number there, but if we're not seeing a number in front of a variable, the number is always 1. So the coefficient of x would be 1, so we call that number b. And then the constant, which is a number that stands alone, right? It doesn't have a variable beside it. That is our c, all right? Which is the number -6. So we know our a is 2, b -1, and c -6. So now we're going to go ahead and find AC. And AC is A times C. AC means A times C. And A times C, that is 2 times -6, -12. And our value B, which we have, is -1. So now that we've done that, the next step is to find the factors. So I'll give you just a sec to get that digested. And then we're going to find factors. Right, so now we're going to go to our factors. And for the factors, what we're doing, we're finding two numbers. When you multiply them, you get -12. And when you add or subtract them, you get -1. And those two numbers would be 4 and 3. When you multiply 4 times 3, you get 12. And when you take 3 from 4, you get 1. So now we're going to go ahead and put in our sign. And our sign for this is, given that AC is negative, then one term or one factor is going to be negative and one is going to be positive, right? And we can now look at B to tell us what is going to be negative and what is going to be positive. And if B is positive, then the larger factor is positive. And if B is negative, then the larger factor is negative. So looking at B here, it's negative. So we know that 4 is going to be negative and the 3 is going to be positive. So that's how we find our factors. Now let's go ahead and write that in. And for these two factors, they will be replacing this -x. So we have our 2x squared at the front just the same. We have our -6 at the back. Now in the middle, we're replacing that -x with these two factors that we have found, and it's going to be -4x and plus 3x, or you could say positive 3x. All right, so we go ahead and we put -4x and positive 3x, or you could just say